Hi, my name's Abby Noblet, and I'll be talking to you about the effect of Ritalin on working memory in children with ADHD or attention deficit hyperactivity disorder. It's characterized by inattention, impulsiveness, and hyperactivity, and ADHD affects the working memory of those that are diagnosed. Now, Ritalin is a very common drug that's prescribed to aid the symptoms and treat ADHD. It's a type of psychostimulant drug called methylphenidate, and this is what I'll be referring to throughout most of my presentation. So my stance in this essay will be that Ritalin enhances the performance of working memory in children with ADHD. I'll be talking about how verbal working memory is improved in boys with ADHD when medicated with methylphenidate. I'll be talking about how it's effective in aiding working memory over the long term, and how it is also transferable to real life settings. So my first source, it examines the effects of methylphenidate on verbal working memory in children with ADHD. The participants included 14 boys with ADHD and 12 healthy controls. The boys with ADHD were each tested twice, once without medication and then once with medication. So they were tested via NBAC tests, and it tests verbal working memory. There were 0, 2, and 3 back tests that were used in this experiment. There's a little diagram in this slide to kind of explain what an NBAC test is. They recorded behavioral measures, so it was the reaction time and accuracy of the NBAC test, and functional measures, which were brain scans done with a functional MRI machine. Now they scanned the brain and determined what parts of the brain were being activated and how strong that activation was when participants were performing the NBAC tasks. So I'll go through the results on the next slide, but basically to sum this source up, healthy controls performed better on verbal working memory tasks than unmedicated boys with ADHD. Once the boys with ADHD were medicated with methylphenidate, the deficit was no longer apparent. So these are the results from the first source. I'll start off with the behavioral ones. So the reaction time for the NBAC test, the control group was overall the fastest in all of them. And then the ADHD group, methylphenidate medicated, was faster than the unmedicated group as well. Now let's look at the accuracy of the NBAC tests. Again, the control was the highest in all of the tests. However, in the accuracy, the medicated group was very on par with the control group. The unmedicated group was lower, especially with a 3-back test where they were way off the mark. This is also due to the challenge level of the 3-back task. It's quite high. Now in the 0-back test, there wasn't a whole lot of difference between all 3 groups. And this is now because the 0-back task isn't very challenging. So now the functional results. After looking at all these results, again, the 0-back test, there wasn't a whole lot of difference in neural activation. But there was also less activation, even in the medicated groups in ADHD. There wasn't a whole lot of change. So after interpreting these results, it tells us that while there was a noticeable difference in the ADHD medicated group in terms of recorded behavior, the neural activation patterns that translate into these behaviors are unclear or only marginally changed with medication. So now the weaknesses of this source was it's old, it included only boys, it did not include a placebo, and it had a small sample size. Now the strengths, it's a reputable source, so it's a peer-reviewed journal article. The findings are consistent with other studies, and the sample is heterogeneous in the fact that it includes subtypes of ADHD in the sample. This just means that the study could be broadened and generalized. All right, so now we'll go to my second source. This investigates if methylphenidate use has an ongoing effect on working memory over a long time period, so over 2 years. The participants in this group, there were 94 of them, and they were aged between 8 and 18 years old. Now, all of them had already been using methylphenidate for over 2 years. So these participants were broken down into 2 groups. There was a continued treatment group, where they discontinued their treatment for 7 weeks. And then there was a discontinued treatment group where they were gradually withdrawn from methylphenidate for 3 weeks. And then after that, they were placed in a placebo for 4 weeks. So specifically, this experiment is seeing if the discontinued group has a decrease in performance once gradually withdrawn to the placebo. Now, this was a double-blind experiment with the use of a placebo again. So this means that the experimenter and participants were unaware of who was receiving what particular treatment. Now, the task that was used to measure this was a neurological computerized task called memory search letters task. So the results. So fewer errors in this task meant the better working memory performance. The discontinuation group had less accuracy than the continuation group, which was expected. And the continuation group accuracy actually improved by the end of the 7-week period. So this definitely concludes that methylphenidate is effective over long-term use. Now, the strength of this experiment was that it was a double-blind experiment, as I mentioned before. It uses a placebo and it is quite a recent study. The weaknesses only observed effects of discontinuation over a short period of time, 7 weeks. There was no baseline assessment prior to the discontinuation trial, and it was a small sample size, even though it was larger than my first source. All right, so my third source, it's quite an interesting one. It uses virtual reality. So virtual reality creates a virtual environment that has 3D stimuli within it, and it's useful for recreating a real life setting. So basically, within this virtual reality, the participants performed an end-back task, and this assessed the effectiveness of methylphenidate. So it is quite similar to my first source. Now, the participants, there were 23 children with ADHD and 12 healthy controls. The children with ADHD were again broken down into 2 groups, and they were tested twice, sorry. They were tested first unmedicated, and then they were tested again after they had medication. Now, it was measured using a functional near-infrared spectroscopy. Now, they used this instead of a functional MRI, because a functional MRI, you have to be supine to actually get measured, the brain activity, whereas this, you don't have to be supine. Now, the results. So after medication, in the 1-back task, there was shorter reaction time. And in the 2-back task, there was shorter reaction time, less variability in reaction time, and more accuracy. However, in terms of actual performance in the end-back tasks, there was no difference between controls and ADHD group. This may be because in virtual reality, it's a more immersive environment, and this may have increased the motivation of the ADHD patients, and then they performed better. The strengths of this source was that the classroom environment assimilates a real life setting. It's very applicable for school-age children over a computer-based or laboratory-based test. It's a very recent study, and it has more female representation in this one. The weaknesses, the results aren't as consistent with other studies, no placebo, not double-blind, and the sample size is quite small. So my overall strengths with all 3 sources, they're consistent throughout the studies for the most part, reputable sources, a variety of different experimental environments. My weaknesses, the sample sizes were quite small, the participants were mostly young boys, and one of my sources was quite old. In conclusion, my evidence does support my stance on this topic quite well, and the evidence also covers multiple types of working memory and contains multiple different testing conditions to support my stance. And these are my references. Thank you.